outcome 18 is describe an experiment to measure half-life. Now, generally when you're describing an experiment, it's a good idea to draw the apparatus rather than just list it and then describe how to put it together. Okay, so if you were trying to measure the half-life of a source, you would need a source. You would need a detector. And our detector here is a Geiger-Müller tube, which I've abbreviated here just to GM tube. The detector is connected to a counter. And one other thing that's important about the setup of this apparatus is that the distance between the source and the detector needs to be what we call within alpha range, i.e. about 2 centimetres max. Otherwise there's a risk, right, that you're not going to collect any useful data at all. And then what we did yesterday, with no source present, take a reading of the count rate. So remember, we're using this phrase count rate rather than activity because we're only measuring a small fraction of that total activity of all the radiation actually being produced. So that fraction we call a count rate. So we get the background count rate. Now introduce the source. And take regular readings of the count rate. So for example, when we were doing it, it was every minute. Subtract the background count to correct for background radiation. And then plot a graph of this corrected count rate versus time. Use a graph to work out how long it takes for the count rate to half. One other piece of apparatus I've just remembered and didn't include. You would need some sort of timing device. Now I was using the computer to do the timing yesterday, but I've just added a stopwatch up beside my diagram to do the timing. This note, like I say, it's not actually a learning outcome, but I'm just going to give you a few wee brief notes on some of the ideas of safety in case it comes up. So the first thing is the hazard symbol. Basically, you can see it in a triangle, sometimes it's not in a triangle. Okay, straightforward enough. Sure, you've probably seen better drawings of it than that, but gives you the basic idea. To protect someone from radiation, we can shield them, so that means putting something in the way to block the radiation, and that would have to be appropriate to the type of radiation involved. Right? There's no point in putting thin aluminium with a gamma source, for instance. Okay, increase our distance from the source. So we talked about a dentist leaving the room. Quite often, with really strong sources, say in a nuclear power station, they'll do it remotely using robot arms. Okay, so they're not near the source. And lastly, reduce time of exposure. And then the last wee bit, so it's just general safety. Sources should be locked away when not in use. And then wash your hands or remove gloves after using a source.